friends, and welcome to the case walkthrough of collecting scarves. In today's case, we're going to be looking at a situation where we have to collect scarves from a variety of cities. In the first few levels, we're going to be traveling to those cities. We're going to be initially identifying which city a scarf is in. We're going to be determining the distance and the cost of traveling to that city. And then we're going to be looking at a situation where we're buying multiple scarves and traveling to multiple cities in order to do that. We'll then switch gears and we'll start looking at manufacturing scarves, where we're going to be identifying first what color elements exist within the scarves that we're given. We'll be then building on that and traveling to a city and looking at all the scarves that are in that city and manufacturing those. We'll be manufacturing multiple scarves. And then we'll be looking at the situation where we have a choice between traveling or manufacturing the scarves and making a determination on what the lesser cost would be. So let's go ahead and jump right in. We'll take a look at our data set to start with. So we're given a table that has the cities, it has the coordinates, it's got the information about the scarves, as well as the scarf code. That's going to be a really important field as we go. Once we get to the manufacturing elements, we're going to be using this table a lot more, where we have the abbreviation and color and the cost of those colors. So I'm going to start off by reorganizing this table a little bit so that we can turn it into some named ranges that are going to be easier to use. To highlight my table, turn it into a table so that I can reference that. I'm just going to give that a name, table scarf. And then I'm going to also create a table for later. And I'm going to call this one table colors. So we'll come back to that one. All right. So to start off with, the first level is going to be pretty simple. We're going to be just identifying what city the scarf lives in. So we're going to do that with an XLOOKUP. Because we set up our table, it's going to be really easy to reference that data. We can reference our scarf table. We are going to be looking up based on the scarf code. And then we want to return the city. Off to a great start with the formula error. Got to remember all of your brackets. We'll copy and paste that down, and we now have all the cities where those scarves are located. All right. Next up, we need to start identifying where the city is located. So we're going to build on what we had. We've got to first look up city, and then once we know the city, we've got to identify the X and Y coordinates. We've got to calculate the distance between that and the starting city of Vienna, which is always going to be at coordinates 48 and 27. So I'm going to start off here with just putting my X and my Y. We're going to need multiple cities in the next level, so trying to set this up so we can leverage some of that logic later on. So these are going to be our starting X and our starting Y coordinates. Next up, we want to identify the ending X and ending Y based on the city that this scarf is in. So we're going to use some similar logic. We're going to use an XLOOKUP here as well. We can remember back to our table that we can look up the scarf. We'd be able to get the X and Y coordinates directly. So I'm going to go ahead and do that. We're going to look up our scarf. We're going to look that up in our scarf table. And then we're going to return those X and Y coordinates. So we do X coordinates, and we can actually do that for the X. We're going to copy and paste that for the Y as well. And then our distance per this calculation is going to be 100 times the square root of the difference in the x-axis squared, the difference of the y-axis squared. So just a standard Pythagorean distance. So we want it to take an absolute value of the difference. It doesn't matter if it's lower or higher. We just need to know the difference between the coordinates. So difference in the x coordinates squared plus the difference in the y coordinates squared. Mess that up. Get the y coordinates, doesn't matter what order we put them in. Close out all the brackets. And so we have our difference, and then we do need to take note of rounding. That can be very important a lot of times. In this case, we want to round to the nearest integer. at that ending calculation point. Of course, got to tell it how much to round to. And so we have our calculation steps. We can copy these down and then just reference those answers. All right, getting a little bit more complicated. Now we need to do the same thing as we did in our last step, only this time we're going to be traveling to potentially 3 different cities in order. In some cases, we'll have some duplicates. I think one of these early questions is actually you don't have to move between cities. Yep, scarfs 1 and 2 are both located in the same city, so there's no distance between those, but then scarf 3 is located in a different city, so we're going to have to travel. So we can borrow this logic because we're going to want to go to each set of coordinates. Instead of ending x and ending y, we're going to call that x for the first scarf, so x1, y1. We want an x2 and a y2, and we want an x3 and a y. And between each of these points, we're going to want to still calculate the distance traveled so we can sum those up. I'm actually going to give us a break in between each one of those. We'll want to bring down our distance formula here as well. Call this distance 1, call this distance 2, and distance 3. And ultimately what at the end is going to be the sum of all of those distances. And we don't want to round until the end, so I'm going to remove the rounding on these interim calculations. Just calculate this over, and then we can do a round of the sum of those. And of course, we'll have to go fix the actual formulas. All right, well, let's take a look at this. We just need to adjust the scarf, lookups, do the same thing here. And actually, I'm going to change this lookup. So we want to actually return both the x and the y together. We can actually do that by referencing both columns, and then when it returns, it's going to return both the x and the y because those are in the order in the table. And so we can do that with one formula, which is just going to make it a little bit easier when we want to copy these over and adjust those references. We can do the same thing for our third points as well, making sure we reference scarf 3. We can check our distances. We want to make sure that this is the distance between, I'm actually going to give us a little break there so we can copy that formula over. So this is now the distance between those x and y ones and the starting x and y. Should be able to verify. These are now referencing the distance between each successive point. And then we're going to sum up those 3 distances, making sure it's rounded. And we, of course, need to add in the cost of the scarves as well. In this case, it is saying that every scarf is going to cost 15. So we're going to add 45 to that total, 5,514, matches our answer. We can just copy that down. And bring those answers over. All right. So now we can move on to thinking about the colors and the manufacturing elements. So in levels 4, 5, and 6, it's all going to be about the manufacturing and understanding the cost of the elements and the cost of setup and such, but they're going to build on each other. So for the first one, we just want to understand how many of a specific color element exists within the scarves. We remember back to our table here, it gives us the abbreviation, the color, and the cost. So we're going to need this abbreviation and color for this first step because we need to look at the color that we're given. We need to turn that into the abbreviation, and then we need to count how many times that appears across the 3 scarves. So we can convert this color into the abbreviation with an XLOOKUP. So we can do color. We had already set up our, well, thought we had set up our table. I named it table colors instead of T. Just go ahead and fix that. So we can do an XLOOKUP on our table of colors. We want to look up the color, and we want to return the abbreviation. So that's going to give us the letter that we care about. And then in the next step, we're going to want to know how many times, in this case, the B shows up in there. So one way we can do this is a handy little trick looking at the length of a text string when we substitute out a specific text string with a blank. So in this case, I'm going to start by looking at the length of the concatenated view of all three of these scarves. And then we're going to subtract the length of that if we first substitute. So we're going to substitute from that same concatenated 3 scarves. We want to substitute the abbreviation, reference that cell, and we want to replace that with a blank. And so that will replace every time it sees the B with a blank. And so the difference in the length, because the characters are always, all the abbreviations are always one character, it's going to give us the number of times that character appears in all three of these combined. And we get a 3. We can combine these formulas, which we will actually need for later. So I'm going to do that here. Going to embed that XLOOKUP within the formula. We get the same answer. And then the last thing I'm going to do in order to facilitate some of the later levels is going ahead and setting this up with a single input. So we're going to say those are the scarves, is these 3. And then we are going to replace those concatenations with the scarves. So then we have one input with the color and one input with all the scarves. And we do get 3. We can place that, we can copy that down, get all the right answers. All right, I'm going to bring this down because we're going to make some revisions here. In level 5, we're going to be looking at a specific city and color. And the first thing we're going to want to do is identify all of the scarves that are in that city. So there can be different numbers of them. There's at least 1, but there's no more than 3. And we want to do the same logic as we did in level 4, but on that varying number of scarves. So we're going to leverage a filter function in order to get the scarves that we care about. We want to filter the list of scarf codes based on the city being the input here. So in this case, you can see it returns the 2 scarves. Trying to get some examples that might have more. In this case, for Athens, there's only 1. So that filter function is going to just give us the list of them. And then now we're able to substitute this into the formula we wrote last time. So we can grab this filter function, which gives us a list of scarves. And we can just replace that input where we had the scarves input from before, from the list above, with this new filter function. And then it's going to concatenate that into a single string in the later parts of the calculation. So we can, well, we should be able to use this. Oh, I forgot to update my color reference. That was the problem. That's going to help us. So now we get the 6. Copy that down and bring that into our answer sheets. And boom, it works. All right, and for this last sort of just on the manufacturing side of things before we get to level 7, we're going to be looking at the cost to manufacture these 3 scarves. We're going to need to do some similar logic as before, where we want to know how many elements of each color exist, but we're also going to need to then put that against the cost per element from this table. So we're going to borrow some of that logic and that we used in the prior couple of levels, and then we're going to combine that with looking at some calculations across all of the colors. So let's start by grabbing this formula and we're going to make some modifications to it. So in the case of level 4, we were given a color that we cared about, but in this case we care about all of the colors. So ideally, we're going to do the same logic of counting up each color across all of them. So let's just kind of build out some of these steps. We have the full list of the colors in our colors table. So we could look at this abbreviation and we can see all the letters here. So ideally, we're going to, for the combination of all three, we're going to be able to add up the number that each of these appear. So we can substitute that into our prior formula. So instead of looking up one color, we actually are going to want to, actually we're not going to look up at all. We're going to remove that. That just returned a single abbreviation. We actually want to do this across all of them. So we can put this T colors abbreviation here. That's going to be this range V, W, S, G, Y, R, and V. And then it's going to perform this calculation for each of those. And you'll see if I do this, that initially just gives me a count of each one. So if we put this side by side with our colors to test it out, we can see that it says there's 6 Bs, and we could look at that. Those are all in scarf 3. We can see a whole bunch of Ws. We can sort of do a visual check that there's no S's or Y's or R's or V's. So that looks to be working properly. And what we want to do then is take this number of each color element that appears and multiply that by the price. And so that is also in our colors table. So if we just bring in the cost per element, we'll see these are the different costs for each of those ones. So to get the sum total of all of the costs for the elements, we're just going to multiply those together. So we can wrap this formula with a sum product of that cost per element. That's going to be one range. And then the other range is going to be essentially what outputs the, well, that kind of messed up my formula. We're going to do sum product of the colors, the cost per element, and that. I got rid of the let there. Okay, so this should work. Let's see if it does. All right, so now what we have is the total cost of the elements. That's the $84. So we see that matches to the example that we got. In addition to the cost per element, we're also going to have to add up the setup cost. In this case, there are 3 scarves. So we just need to add $600. And we can also see in every case in this, in level 6, there's going to be 3 scarves. So we want to add 600 every time. We're actually going to be adjusting that for some of the bonus problems, I think, later on. So we'll have to adjust at that point. We can take our formula now and we can copy it into all of level 6, and we can see that works out properly. And now on to level 7. So in level 7, we are going to be doing both the traveling to collect and purchase the scarves at 15 for each scarf, plus the cost it takes to travel, and then comparing that to the cost of manufacturing, inclusive of that setup cost for the scarves. So we're going to do both calculations from level 6 and from level 3, and then do a comparison between the two. So we'll start by just copying down the logic from level 3. And we could clean it up, make it a single cell formula, but just not going to do that for now because I think this should be quick enough to work. We are still starting in Vienna, so we can always use that hard-coded start X and start Y. We'll want to make sure that our formulas have updated, so they are referencing scarf 1. Our distance formula still looks good. Scarf 2 and 3, so that all looks good. So this is going to be comparison point 1 is going to be the cost of doing the traveling. So we can see that that does match. So 2,376 does match the example. So we'll highlight that. That's going to be one of our points of comparison. And then the other piece that we want to grab is just the formula that we wrote in the last problem. So we're going to bring that down. right next to this one, and then just adjust all of our references. So we want to adjust the scarves to be here. There's still always 3 scarves, and we can see that that 802 does match the example. So those are the 2, and then the answer that we want is going to be the minimum of these 2. So sometimes it will be cheaper to travel, and sometimes it will be cheaper to manufacture. Now we have everything set up. We can copy all these formulas down, and then we can reference them in our answer. There we have it, level 7. So pretty simple. If you were able to get level 6 and level 3 well built out so that you could copy it and borrow all of that logic. Of course, more could be done to simplify these formulas and make them into single cells more easy to copy, but for the purpose of this was easy enough to build off of those. So now let's take a look at the bonus questions. So these ones don't relate to any particular level, so they could be done at various times throughout the case. But I think in a lot of these, there is some elements that you learn while doing the problems that makes it a little bit easier to handle at the end here. So just go through them. So first, we're going to be looking at the city that has the most scarves and which city that is. So one way that you could do that is creating a unique list of what the cities are. So we'll just reference that. Just tells us what the cities are, and then we want to do a count if on that city versus that unique list, and that's going to tell us how many times each city shows up in this list, so how many scarves are sold in that city. We could scroll through and see that Budapest has the most. We want to do this formulaically, especially if this list was a lot longer. We can do a quick trick with XLOOKUP. So if we know a sufficiently large number that's going to exceed the highest possible, we can put that in there and we can use the approximate match functionality to help us identify what that most common element is. So we're going to look at the count of times the city appears versus the list of the cities. And then we're going to choose to do an exact match or next smaller item. And it's for that next smaller item that's going to be key. So it's going to obviously not find anything that has 9,909, but it's sufficiently large it's going to pick up whatever the largest is, which in this case is 3. And so that's Budapest. Put that in here. The next thing we want to do is a pretty similar concept, but this time we want to identify what scarf code appears the most in all of these levels. So a lot of times I'll just grab a blank sheet and I'll just start stacking up the data so we can stack up all the lists of scarves, excluding the examples from all the levels. In this case, we've got 3 columns, so we can also just embed a to-call function that will take all that and stack it to a single column, just easier to work with later on. I think we have to do that a few times through here. Scarf codes there. All right, so that should be all the levels. So now we get a nice long list of all of the scarf codes. And then again, we're just going to do that same unique to get all of the unique options that appear. And then the count if, or count ifs would work fine too. The range against those criteria. And then an XLOOKUP. Again, just need a sufficiently large number. -1 for that approximate match. And then this will be the scarf code that appears the most times. Sometimes these questions will ask you what or how many times it appears, so do be careful to read the question very carefully, determine if you need to input the item that appears the most or the amount of times that it shows up. All right, so next up, we want to know how many scarves in our data tab have blue as the first color element. So looking back at our table, that is really just looking at how many times does the B show up in this first column. So that is going to be a count if, and we're just going to look at this column, and we want to know a B. And so that shows up 24 times. In this case, it says what city has the most red color elements across all of its scarves. So one easy way to set this up is to add another column here. We can do a count if for each scarf across all of the elements of that scarf. We care about the reds. And so that's going to just add it to our already formatted table. And so this is going to count for every one how many reds show up for every single scarf. And then what we care about is what city has red show up the most. So we already have our list of unique cities here. We can borrow this section and we can do a sum if of, and I just prefer to use sum ifs so that my sum range is always the first parameter. So we want to add up this count, which again was just the number of times red appears in the scarf elements. We want to sum that based on the city, and then we'll use this, we'll use this as our list of those cities. And so this is going to tell us the sum total for each city of that red element, that column that we created. And again, we want to identify the city that has the most red, so we can actually just borrow this formula here, adjust it so that we are looking up in these numbers, and we want to replace this back with the city list. So identify the largest number that appears here, which again is our total of red elements for that city, and return the city name using that approximate match because we want the one that shows up with the highest total. That in here. And then on the last question, we're asked how much would it cost to manufacture all of the scarves on the Scarves tab using the logic from level 6. So if we go back to level 6, this is where we had built this formula that lets us look at multiple scarves at once. This is actually going to be really easy to adjust to the needs of that bonus question. So let's just go ahead and grab this one and bring it up here. We are going to need to make some adjustments. So one adjustment we have to make is this formula was set up based on the manufacture of 3 scarves, with each setup cost being $200. So now we have to do it across 100, so 100 times 200. And then the other thing that we need to change is this input, that is the list of scarves, because we want to do this across all 100. We just need to reference that full list of scarves. So we can come over here and highlight the column, or again, we can reference, we've got that table, so we could do the T scarf and get the full list of scarf codes. And we'll see that very easily translates and gives us the right answer. There you have it. It's a walkthrough of all of the levels of this case. Lots of XLOOKUPs, definitely recommend setting up a table. In some cases, making adjustments to that table or adding additional helper columns, but that made it really easy to reference those things throughout. And then in this case, I think there are a lot of elements where you could borrow logic from previous levels and build on it, so definitely look for opportunities to do that versus rebuilding from scratch each time. I think the other element that I might just caution on is around some of the setups like this. It worked for here to be able to set it up in multiple columns. Of course, it became a little bit messier when we started having to do multiple scarves. If the levels are getting a lot more complex, it might become helpful to either set this up as a data table or to set it up as a more complex but single cell formula, or even building out a Lambda function that you can use later throughout the case. But overall, a very fun case. Hope you all enjoyed.